Hi, everyone. This is Javier from Polling, and I'm here one more week with my friend Dan. This week, we're going to talk a little bit about AI and the history of AI and how AI is relevant. Welcome, Dan.
Thanks. Well, I'm excited to have this talk again, and yeah, I'm looking forward to talking more about kind of where AI started and the history behind it, and maybe talking to some theories that we both have around artificial intelligence and machine learning.
Mhm. So let's see, where did AI start? I think when people talk about, we should have written notes instead of trying to recall this from memory. But when people talk about the origins of AI, I think it all comes down to a conference that happened. I think it was in the 50s, right? McCulloch was the name, and people started thinking about, well, how to build computers that did smart things. You know, that is uh, there is this saying that I like very much, that people use in computer science for many years, which is AI is anything that we don't yet fully understand. So the definition has changed a little bit, right? Back in the day, playing chess was AI. These days, you would say, well, maybe that's not really like top of mind AI. It's just like, searching graphs or like heuristics or whatever. And for the longest time, you would think of like top AI as like, I don't know, playing games, right? And because games were like an example of human intellect, and now it's like, well, maybe that's just not really top of mind either. I think there was a lot of interest when computing was started, in the 50s and the 60s and so on, in building computers that did smart things, meaning things that humans typically do, right? So people started building all sorts of programs, or what passed the programs back then, like punch cards and stuff like that, to try to play games, try to play like tic-tac-toe and checkers and chess and Go and so on. And I think a lot of those things were very, very complicated. Like the capabilities of computation were not ready back then. And then a whole bunch of things happened. One of them was people realized that programming computers from scratch to do smart things is very complicated. There are so many things that we just don't know how to do. We don't know how to program computers to understand text. We don't know how to program computers to play complex games. A lot of those things are very, very hard. So then is when folks started having this idea of, what if instead of programming the computer and tell it exactly what it needs to do in every single case, we just go and let the computer learn, right? We just take a whole bunch of data and tell the computer, you figured it out. And then the computer sometimes can figure it out. So this works really, really well for many things, right? It works really well for understanding audio. It works really well for understanding text. But I think some of the early success stories of this idea, it's called machine learning, of course, is when you had computers that could understand scanned text. Like you would write something by hand in a piece of paper and then scan it and then pass it to the computer, and the computer would be like, yeah, here are, what the letters mean. Now, of course, like you can do that on your phone, right? All day long, and like nobody's surprised by it, right? But this was actually very, very, very hard to do, right? Like nobody knows how to program this mapping between pixels and letters or whatever. Um, then I think there was this period in the 80s where folks believed that we would have intelligent robots and so on, right? Like, what science fiction writers have been talking about for many, many years, right? Because, Kurzweil and all these people were building the systems that could synthesize voice and understand voice and recognize text and so on. So it's very easy to go and speculate and say, well, these problems are solved. Of course, now we know it wouldn't be solved, and it was, very, very hard to do those kinds of things, and the compute capacity was just not there. So it would have been impossible for them to solve these problems then and there. We would need another 30 or 40 years to actually go ahead and do that. So one of the things that people sometimes talk about AI is like the notion of AI winters, right? I don't know if there's also an AI summer, but there's definitely an AI winter. It's this period when people realize, oh, this stuff is just too complicated. And then, companies go bankrupt and, they lose investments and people realize, yeah, it's not going to be that useful. So there have been, I think, two AI winters so far. I think one was, after this initial phase in the 60s and 70s when people started building the first systems to play chess, and then they realized, oh, this is very, very hard. And then in the 80s, after, they kind of realized that, creating some of these things, was very hard, it kind of, died down a little bit. Some people say there's going to be another AI winter. Oh, I don't think so. I think this time it's a little bit different, but maybe we can talk a little bit about that later. And then, of course, the thing that happened in recent AI history was this kind of notion that you could create much more complex machine learning systems, right? These things are called neural networks. The details that matter, right? But basically, very very complex machine learning systems that use a lot of compute capacity. So the two things or three things that happened in the 2010s. It's kind of funny to talk about the 2010s as history, right? But it was already like 50 years ago. But there are a few things that happened. One of them is we started having a lot more compute capacity, right? So just more computers and using GPUs. GPUs are like graphics chips that
Mhm.
people use for playing video games before, and now they're actually used for AI. And then the second thing is people figured out ways to create machine learning systems that are more complicated, right? Like this is basically what Hinton won the Nobel Prize recently for. Basically this idea of how to build these more complex machine learning systems. And then the last thing is you start having a lot more data, right? Like back in the day, if you wanted to build these things, you have to create your own manual data set. That's expensive, right? And then with the internet, there's tons of data you can use for a lot of different things. So in my mind, the modern era of AI began in, I think it was 2009, 2010, when AlexNet, I think was the name of it. There's this system, which was a neural network AI system that could recognize objects in images. And this was back in the day a very, very, very hard problem. Like imagine, if you're a like old style programmer and you have to understand, what is an image, what isn't there? Is there a sky? Is there an object? Lines and textures and objects. Like this was incredibly complicated. And then came these guys with a neural network that was very simple, super simple architecture. Like you could basically describe it in 2 minutes, and then they achieved performance that was beyond anything that anybody had been able to do before, right? Because the compute capacity was there, because they had enough data to train this thing, and they achieved massive success. And in my mind, and they did it, leveraging these GPUs, right? And in my mind, that was essentially what kicked off the AI era of the 2010s. Like people like companies like Google have been using a lot of AI for many different things. But I think when kind of things started and folks realized, okay, now we are reaching the third major phase of it. That was probably around the 2009 2010 when AlexNet came out.
Yeah. That sounds like, is that, and just for a question for me, is that similar to, we kind of do CAPTCHAs when we test, say, "Hey, is this have a" highlight every picture that has a dog. Is that kind of similar where it was finally able to identify and solve those kind of those pictures?
Yeah, yeah, exactly. So,
Okay.
back in the day, if you fed there was this story about this data set. It's called ImageNet. That was compiled by Fei Li and her team at Stanford, where they took tens of thousands of images, and some of the images were, it's a cat, it's a dog, it's a truck, right? All those different things.
Not hot
So,
dog.
yeah, yeah, it's is it a hot dog or whatever, right? So this was in the early 2000s, even in the early 2000s, this is incredibly difficult. Like the way people do this would be creating these super complicated systems that try to process every pixel and try to understand, what is the kind of texture here, or are there, divisions of color, or large areas of color that may indicate an object, trying to build graph representations of it. It was really, really hard. And then came this team that used a pure machine learning approach. They created what's called a convolutional neural network. It doesn't really matter, what the details are, but it's basically a very, very simple architecture that just processes the pixels in groups and then kind of groups them together into larger things. And then they just fed, this tens of thousands of, uh, or more, right? Like maybe even hundreds of thousands of images of association between what is in the image and an actual representation of, like a text or, or an indication of what is in that image. So they fed all that, and the system learned on its own, and then it was able to perform much better than any human-made system. So the previous state of the art was like, I don't even remember, it was like, I don't know, 20, 30% of objects recognized. This system was able to do like, 60, 70%, like so much better. Like the progress was like 1% better per, few years, right? And then it became suddenly they were able to do it like twice, you know,
Yeah.
twice as well as before. So um, yeah, I think that was what kicked off a lot of the AI work. This was
Yeah.
basically what Andrew Ng and other people were building. Then, at Google, right? Like, there were many other things that were done later, right? I think um, people started building on all sorts of models for, you know, understanding voice and generating voice, right? Because of course, when you have a phone, right, like that's what you want to do. You want to be able to understand and generate voice. People started building on ways to understand and recognize text, for example, and so on and so forth. I think the second kind of key point or key moment was in 2017 when a team of researchers at Google came up with this notion of it's called a transformer and this concept of attention. Again, the details don't really matter that much, but there was basically a way to design uh, uh, a machine learning neural network model architecture that is able to learn all the intricacies of text. Like, it doesn't seem like it. It seems like, to humans, text is not as complicated as images, but that's not the case. Text is
That's because we're the
incredibly.
best version of AI.
Yeah, yeah, yeah. So text is very, very complicated, right? There's all sorts of rules. There's all sorts of knowledge that is encoded in that text. This was the reason why when people were initially thinking about AI, they came up with this notion called the Turing test, right? Which is, how would you distinguish whether an AI system was truly intelligent or not? And the idea was to talk with that system using only text, right? So you couldn't see, if a person or a computer was on the other side of that communication. And then the system would reply, and then you would try to, ask questions, right? To try to understand, are you a human or not? And I mean, I would say we're probably way beyond that, right? Like, if you go and tell, ChatGPT or Claude or Gemini or whatever, say, hey, pretend you're a human, let's have a conversation, right? Like, an average person that has never seen one of these things would not be able to recognize that this is a language model instead of a human, right?
Have you read the statistics about this recently?
I haven't.
No, you haven't. So I was reading an article the other day, and I might be wrong on the specific number here, but it's like 1 in 3 conversations that are happening on Tinder or, like, dating apps are more than likely a chat bot or a fake person, right? Not a fake person, but, like, an artificial intelligence chat conversation. So, people are falling for it. We're clearly much, much further past the Turing test if it's this late.
Yeah, yeah. I mean, I can 100% believe that, right? And if you had told me, 70% of people, for example, cannot distinguish a chatbot from a real person, I'd be like, yeah, I mean, I can easily believe that.
Art. I mean, I mean, I think on Telegram, on WhatsApp, you get random people hitting you up all the time, and they're more than likely bots,
Hmm.
and it's just efficient now.
Yeah. Well, I mean, the systems are got really good. But a lot of it basically stems down to this idea or this set of ideas, which is the key piece that was missing, right? Like, so text was very complicated, and then we had only so much compute capacity. So this idea of a transformer and attention was essentially what enabled building really large, really complex models. And then after that, everything happened very, very quickly, right? So Google released a whole bunch of models that were called P5, and then OpenAI was created, and then they started building their GPT models. And then, of course, many other people came through. And I would say the moment when the general public or like everybody else started being aware of these things was when OpenAI released think it was ChatGPT 3.5. I think it was like October 2022, something like that.
No, I think it was it October or was it, like,
Yeah.
December? I think it was, like, December because I'd just gotten
Or
back from
September.
traveling.
Mhm.
Let's see, it was it the legacy model? The
No, it was
ChatGPT
3.5. At 3.5.
5?
Yeah, so they had GPT-1, GPT-2. GPT-2, they said, "Oh, this is so powerful, we cannot release it." Of course, that was, made no sense. Then I think it was 3, but 3 had a limited release. And then 3.5 was the one that was available to people. And I think was when everybody was like, "Oh, wow, this is really nice. Like it can do, all sorts of crazy things, right? Like it can process spreadsheets and generate reports and write,
Yeah,
you know, entire things by itself, right?" So I think that was when everybody kind of woke up to it, and they had a, of course, like massively successful kind of marketing push. They became so popular. I think it was like the first app that got to like, or the fastest website to get to 100 million users, something like that.
not
Um,
surprised.
yeah, no, I mean it was, of course, like it is really useful. It works really well. People were surprised, and then everybody started thinking, "Oh, what can I use it for?" And uh, And now, of course, we have hundreds of different language models. There are many teams around the world that are building these things. I think it's kind of becoming a little bit more incremental. Like the pace of innovation is still incredibly fast, right?
Yeah,
But it's not so much in the models themselves, which I think are limited in some ways by the amount of training data. At the end of the day, there's only, everybody trains on the internet, right? And the internet's only so big, right? And there's only so many other data sets that you can include, right?
yeah.
But I think the innovation is going to come from the application side, over the next, year, a couple of years, rather than the, model kind of size and quality, right? Which is kind of becoming a little bit more stagnant.
Yeah. Well, I just got a question. Explain to me the difference when you use AI and ML, and I think there's the term deep learning as well. I think I get sometimes confused, right? When we reference artificial intelligence, it's not actually AI. It's the ML models behind it that we then reference AI as kind of like the overarching term.
Yeah. So I think people use a lot of this interchangeably these days. So I don't know if it's so clear anymore. But AI, what people used to call AI, was the traditional artificial intelligence. Essentially, anything that was not typical programming. So, a typical programming, you go and describe the function of a system, and then you go and write the code for that system to do what it needs to do. In AI, sometimes you would do things that involve searching. So, for example, if you are playing a game of chess, what you would do is you create a graph that represents the game. If I move, e4, then the other option is, like, you know, e5 or whatever, right? And then you would put all those things in notes in a graph, and then you search that graph, right? So that was a classical AI algorithm. It was graph search. But there are many other algorithms that were very similar, right? So I think people would refer to AI typically as a broader field of creating programs that did things beyond classical programming. Now, the notion of machine learning uh, is, like we talked about, is basically, well, instead of creating the program manually, we just let the machine learn by itself. So we take a whole bunch of data, we feed all that data, and then the machine would come up with the actual program. That's how most of modern AI is done, because the things are so complicated. We don't want to write them by hand. We could, we probably would not even be able to write them by hand. Then there is deep learning, which is basically the exact same thing as machine learning, but with bigger and better. So the problem with machine learning is that when back in the day where we didn't have enough capacity or good algorithms, we couldn't build these really large models. Like these things are very, very complicated, right? Like if you think of, DeepSeek, for example, right? Like the DeepSeek R1 model, I think is 697 billion parameters, right? Like these are, numbers. Like imagine what it is, 697, billion numbers, right? Like that is a lot. It's a lot of data, right? It doesn't even fit in memory in like, most computers, right? Like most people don't have, you know, 700, gigabytes of RAM to store these things, right? In their personal computers. So you had to be very, very smart about how you come up with all those numbers. And of course, the numbers matter, right? If you take a number and then randomly, flip it, the whole system may not work. So it's very complicated. So deep learning is essentially the set of things that enable us to build those things. Now, of course, most of the language models are deep learning models, right? Then there's this other definition that sometimes people use, which is artificial general intelligence or artificial superintelligence, which is kind of a different thing. That is not so much a technical definition as it is a notion that at some point these systems are going to be so smart that they can do anything that a human can do, right? Or even beyond. They can do things that humans cannot do. So I think sometimes people get confused when you talk about AI from the technical side, which is, well, here's a set of programs that you use to do certain tasks, to the artificial general intelligence notion, which is machines are going to, be, super smart, are going to take our jobs and so on.
Yeah, that's like, when we think about in Star Trek, right, when they reference computer, right?
Yeah.
Computer, "Hey, help me solve this," right? Or ex machina when we're talking about this artificial human that, we don't know if it's a robot or not, and it can blend into society. Or Westworld, right, where we saw the actual the rise of sentient, artificial
Yeah,
intelligence.
yeah. We should have said, spoiler alert or something. I mean, I guess some people have not watched Westworld, but now you know that really, yeah, I love it.
I think it's this we live in such a day and era that if you're watching something about the birth of computers and, there's these robots and, we're living in the world of AI, you're like, you can kind of pretty much figure out what's the story about, really.
Yeah, I mean, I should have spoiled that one, but you know, it's fine. We can like when we put the podcast together, we can add a spoiler alert.
Yeah. We spoiled
Like
Westworld a little bit. Um, no, that's interesting. So, talking about kind of what those different language models are, kind of what AI ML is, what do you think of the models out there as your current favorite right now? And what do you think of this whole, deep seek kind of trying to disrupt what we're doing?
yeah, so I mean, lots of things to unpack there. I use a lot of different models regularly. And I think some of them are better for some things, some of them are better for other things. My personal favorite for coding is, which is what I do, on a normal day, is Claude by Anthropic. Especially after the latest update, which today it's February 27th, 2025. When we're recording this, I think this is one day or a couple of days after they released their 3.7 model. It's really, really good. It generates code very well. Um, but I use ChatGPT, I use Gemini, I use DeepSeek every once in a while, and others as part of work, right? Like we use open source models as well, Llama and so on. I think this is an interesting thought, right? A lot of these models, we think of them as programs, right, or as tools, but in some ways it's very hard to say when one of them is better than other, right? Like, if you had a benchmark, you can always say, ChatGPT gets 75% on this benchmark, and then maybe Gemini gets, 74% or whatever.
Yeah.
You can be precise about it, but most of us don't think of them that way. And we think of them, does it solve my task or does it not solve my task? And I think in my mind, these models have a little bit of a personality, right? So sometimes they are, more direct or less direct. Of course, there is a lot of human work that is involved in giving the model the features that it has. But as a user, I think it comes down to, do I, enjoy talking with the model or not, right? Like, does it do the things that I wanted to do? Can it, think about what I want before I even tell it what I want, right? And some of them are really getting that. So I think for me, the way that I would talk about models is it's not so much as, the capabilities as it is the personality of the model.
Yeah.
Okay. So I think Claude, has a nice personality. I like it. I like it more than Gemini. I find Gemini a little bland. Even though Gemini has a lot of, really interesting things, like the context size is really big. You can feed it an entire book and say, find something on page 137 of the book and then contrast it with, something else on the web. And it would do that for you. That is fantastic. It's really, really good at doing those things. But the personality is a little bit more toned down. There's also, Grok 3, which is the model trained by XAI, right? Which is the AI company stemming from X, which is the former Twitter, right? And Grok has a very snarky kind of personality, right? So it's a lot more fun to talk with Grok than it is to talk with some of these other models. Uh, Even though for coding, I haven't tried it yet, right? I think OpenAI is definitely a little bit more um, open to discuss things that may be controversial or whatever than some of the other models. One of the criticisms that people have about DeepSeek is that, of course, because the model was trained in China, there are some things about, Chinese politics, for example, you just can't ask it, right?
Yeah.
I mean, though in other things, it's actually very, very open. So you can ask it all sorts of, like random stuff and it would surprisingly answer. So the other thing that is very interesting, right, and the reason why I think DeepSeek became so popular was because for the last few years we kind of assumed that American companies were leading and there was enough of an advantage over companies in other places,
Mhm.
and I think that turned out to be not 100% true. So in France, we saw Mistral, right, which came up with their own chat models, which are very good as well. And then in China, we saw DeepSeek, right, that came up with this DeepSeek R1, which has really, really good performance across a lot of different benchmarks and works really well. Even though when you try to use it, it's basically like busy all the time. I think the last
Yeah.
3 or 4 times that I tried to use it, I have the free version of it, right? The 3 or 4 times I tried to use it, it was just I was unable, right? Like there was just so much use to it. So, um, but yeah, I think that was essentially what created a lot of the buzz around it, right? The fact that they were able to come up with this really world class model when they were supposed to be like a year or a couple of years behind in terms of innovation. But
Yeah. And was DeepSeek the one that introduced the showing the background reasoning kind of before all the other I mean, I don't know why the other models did they do this before when you could actually see it reasoning with itself as it's trying to solve the problem? Did
I
Claude
think
do that?
Um, no. So I believe the first model that publicly showed that was O1
Oh, one.
by OpenAI. But people have been talking about this idea of reasoning for a little bit longer, right? So this is also like a more complicated discussion, right? But when you have a language model, people typically um, But for many years, people focus on the training, right? Meaning,
Mhm.
the machine learning part of it. Like, what data do you feed to the computer? And how do you feed it? How to process that so the computer learns properly, right? So it's all about larger data sets, better training protocols, and so on. And then the inference, right, which is actually executing that language model, running a program, asking questions, see what happens, was a little bit less of a focus. So then, maybe a couple of years ago, folks realized that, oops, the amount of data is limited, right? Like there's only so much internet. There's only 8 billion people in the world generating data, right? So there has to be something else that helps overcome the limitations of that data. So then folks started thinking about, well, how do we make the model not just spend a few cycles or a few seconds doing that inference, doing that thinking, but actually spend more time. It's called like inference time kind of reasoning. So then this notion of can we get the model to go through things for a longer period of time, evaluating options, coming up with plans and so on and so forth. People thought about, many of these ideas for a while. I think the first one that released this publicly was OpenAI, which was their O1 model. And then DeepSeek came up a little bit after that, right? Like, and that was the reason why DeepSeek was so good. But the novel idea or the interesting thing that they did is for the longest time, I mean, the longest time, maybe a few years, things really move that fast, right? For a few years, people thought that creating a system that did reasoning was very, very complicated and you needed a lot of data, right? So you needed millions of examples of full reasoning sequences where somebody goes, here's the problem, here's how I break it down, here are the different components, how we use each one of those, and then the sequence of steps over and over and over in full detail. And we assumed that that was required in order to have the model do reasoning. So what did she kind of proved is that that was not necessary. What was necessary was just a few examples of reasoning in areas where you can verify that the reasoning is correct. So that means programming and mathematics. Now, of course, in programming, you can run a program. You can run, the program where you can run the unit test. You can verify that the code well, I mean, verify kind of has a different meaning, but you can check that the code is correct. It's the same thing in mathematics. So if you have a theorem that you know is true and that you're reasoning through the sequence of steps, you know that if you get that correct result, then the reasoning would be, I mean, in principle, right? Like you could check, that the reasoning is correct. Now there are other areas where you can't, right? Like if you're trying to solve a business problem and you ask the language model, show me the reasoning for why this is the right strategy for my business. There's really no good way to verify. You would verify it 5 years later. Did you make any money or not, right? Um, but because they focus on this mathematical and programming reasoning, they were able to kind of create this system that learns how to reason in the abstract. So that was the big thing that they did. They were able to do this with a lot less data and a lot less resources than other people. Now, of course, other models have that too, right? Like Claude 3.7 has it, and I imagine, so Gemini 2.0 thinking
Mhm.
also has reasoning. I came a little bit before, and so on. And I think that's super, super interesting, right? The key notion here is instead of just telling the model, run on this question, you tell it, just go through it, munch it over a few times, try to come up with a plan and with a sequence of steps, and then give me only the last output of it. So it is more computationally expensive, right? Like it takes more time, it takes more processing power, but the end result is, of course, higher quality.
Yeah. These reasoning the whole process of them doing reasoning or kind of the models is really interesting because it allows you to kind of use that model as a feedback loop, right? Like when you're working as a team with someone and you need, hey, can you give me feedback? Looking at questions that you can pose to the model, then looking at its reasoning, going through it, you can try to find holes in your questions or things that you're thinking or how you're approaching something. So it's pretty interesting to see how that's being developed.
Yeah, yeah. I mean, and like uh, these systems are getting so good, right? That they can do things that humans like would even find it hard, right? I think it's definitely getting to a point where um you can replace a lot of the things that humans do with models, right? I think there was this chart that I don't have in hand right now, but it was super, super interesting. It was basically a comparison of the equivalent intelligence of a language model. And I think, if ChatGPT 3.5, for example, maybe was the equivalent of a 60 IQ, right? And the GPT-4 came out and maybe that was like 85 IQ. And like you could train it to do certain things. But now we're getting to a point where these models are like 110, 120, 130, equivalent IQ. Like they're basically as smart or as good answering questions as a PhD graduate, right? In
Yeah.
that specialty, right? So, one of the interesting things that I was talking with a friend a while back was the models are getting so good at things like medical diagnosis, right? Like you can, if you take a clinical chart and you feed that to a model like, a GPT-4 or Gemini, and then say, here's all my information about the specific patient, what is wrong with them, right? You can feed it, MRI images and X-rays and the whole, chart data and the kind of conversation with the patient and so on. These systems would do medical diagnosis better than any human doctor, right? Like it's not even close anymore. It's not like, oh, are we there? It's like, they do it, objectively speaking, better than a human doctor, right? Like they may not be able to catch some things, right? Sometimes, people lie to their doctors, right? So they may not be able to catch some other things, but in terms of like objectively, can you go from the symptoms that a person has to like a possible, differential diagnosis? They do it better than humans. They do it better than teams of humans, right? So in so many areas that we traditionally think as these are really super complicated problems on which you need an expert human with, high IQ to be able to figure it out. Now language models just, do that day in and day out.
Yeah, that's interesting. It'd be cool to see the evolution of the Turing test to be a way to see if you're being scammed or being lied to, right? And so we're talking, you're talking about being able to analyze all this data and give you an output in a kind of like a doctor would. But how are they able to tell if you're lying, right? That would also be kind of interesting too.
Yeah, I don't think anybody has trained AI models to figure that out. But it could be. I mean, that would be interesting, right? I guess like when you're like, so if you pay for it, right? Like you don't want the model to come back to you and say, "Hey, no, I think you're lying to me. Why don't you tell the truth?" Like you'll be like, "Hey, dude, I'm paying money to use this thing, right? Now the system is accusing me of lying to it or whatever, right?"
Yeah, but that would be interesting, right? I think that's also kind of a next level of intelligence because we talked about you, and I think this is something we kind of agree and disagree on. I do think that agents and humans, there's this talk about AI is gonna take all these jobs, it's gonna replace everyone and anything. I agree to an extent, AI should be able to replace certain jobs. I do think that humans are superior in many cases versus the AI because although AI is able to process quantifiable data much faster than we can, I think a lot of the interesting stuff happens in the qualitative. It happens in between the data points that aren't necessarily matched by numbers, right? It's the art, the beauty of taking the numbers and putting it into something that makes sense that isn't that's crossing that gray zone, right? And making something happen with it. Um, and so we might disagree on that, but I do think that AI will take some jobs, but there will also be a lot of empowerment that happens to humans with the way they use AI and develop and grow their jobs, their skills, whatever they need to be doing.
Yeah, I think it's very hard to speculate which jobs and how and in what degree, right? It's this it's what is it, the saying from Groucho Marx would say, no, that was Joby Berra, I think the one was the one who said that it's very hard to make predictions, especially about the future.
Yeah.
uh so the way that I would think about it is more in terms of the actual. Oh, sorry for the noise. There's literally a helicopter flying right through my place right now. Uh, I don't know if the sound got it.
I heard it.
If the microphone got it. So the way that I think about it is not so much as um, a comparison between AI and humans, but as AI, as the kind of landscape of things that AI can do. So um, there are things where AI is already better than humans. So like back in the day, you could go and say, data entry. Some people did, some people still do data entry as their job, right? So you take a document, you scan the document and you read it. A human reads it, then puts that document or transfer some of that information into a computer. So like this literally people do this as part of their jobs. You take a form, you have the form and you set the name. The name is John. Last name is Smith. So you go there and read the document and then type it on the computer. We have systems now that are better than your average human, right?
Mhm.
So like humans actually make mistakes, right? Like you could imagine that, humans are perfect. This now humans make mistakes all the time, right? And humans make
100%.
mistakes writing, make mistakes, reading all that. So now you can you can build a system that will scan the document and extract the data and feed that data to another database, another system better than the human. So there are a couple of interesting questions, right? Like one of them is, well, is everything that the person does data entry? No, right? Like they probably do data entry as part of another job, right? So if you are a receptionist in a hotel, you don't just do data entry, right? Like you hand over keys, you check
Yeah.
observations, you do upgrades, you walk people over, right? Like you do a lot of other things. So I think thinking about AI replacing jobs is the wrong concept. I think it should be AI doing tasks more than replacing jobs. Now, of course, the jobs are going to change, right? And going to fluctuate. The same way, if you are, I've been talking about self-driving cars for a while, right? If you are a truck driver, most of the job is driving a truck, right? But you also, help loading and unloading, right? You
Yeah.
also refuel the truck, you do other things, right? So it's not just the self-driving part of it, right? So I think in order for an AI system to really take over a job, all the different parts of that job have to be done, right? Or they have to be broken down in a way that can be automated. So that's why I think a lot of these things are going to take a little bit longer. But at the same time, I think there are jobs that are definitely at high risk of being automated. Anything related to data entry, customer service, answering calls, replying to customers. A lot of those things we're already seeing them being automated. Anything related to driving, I think, over the years is probably going to start being more and more automated, right? Like that was the big promise of Uber, right? Like eventually they would come up with this self-driving systems, and then, when they don't have to pay the driver because the car drives by itself, it would become much, much, much cheaper.
Yeah.
Now we didn't see that, and Uber has actually got more expensive over the years. But that's kind
Hopefully
of
it
how
went
they go.
backwards.
Yeah, yeah. I mean, the moment, so if you go around San Francisco now, like it's full of Waymos, right? there's nothing but Waymos driving around, and they seem to be doing okay. I think eventually they will come to other cities and so on. Uh, but I think the the framework that I would keep in mind is, some tasks are now becoming um, AI is able to perform those tasks. So if a job includes mostly those tasks, that job is probably going to get automated at some point. It's hard to say whether it'll be this year or next year or not, right? Uh, I think for other jobs, we would probably have tools that leverage this AI and then people combine it into, other things, right? Or merge that AI system with something else. It's kind of a little bit hard to say. So, I think we probably won't see these shifts in job market and so on for a while. But we've already seen them, right? So this is not entirely made up. If you look at job openings for software engineers, which is very funny. It's kind of ironic that the first sector to be heavily impacted was software engineering. Like back 3 years ago, there were like 500,000 job openings or something like that. It was crazy. And then all those things in the US alone, right? And then it literally went down drastically. And now we're basically like at pre-pandemic level. It's absolutely crazy, right? Yeah, so like people are definitely automating software engineering jobs.
I mean, I also think AI and these ML models, they all really just help us be more effective, right? Like I mentioned earlier, I think it's like that qualitative and quantitative. I think if you are an effective worker or you work hard and you like to solve problems and you like to create or whatever, these tools just enable you to do more with less. So you don't need to have as big as a team to do something. So it allows people to actually focus on things that matter. I know I when I was in college, I was thinking about going to do a PhD in economics, and I wanted to write something about post scarcity economics, right? When we have no limitations on food, resources, and things like that, what becomes of value? And you've seen things like this happen in Star Trek, right? Where in Star Trek, you can kind of do whatever you want and you can create whatever you want. And I think this kind of goes back into the next thing is like, we previously used to hire someone because we just needed to scale and duplicate ourselves and software engineers to create more and do more or hire people. Now we pretty much have every tool we need at our fingertip and someone who can help us do that, right? So you can have generative AI create you advertisements. Very simple. And you advertise with those advertisements. If you know what advertising you need to make because of your gut and your niche and the way that you look at the world or the problem you're approaching, you're focused on the fundamentals of the theory. And then the execution is able to happen because you don't need to hire someone to do that. You have the tools to do that. And so I think it's going to shift our foundation to being able to say, hey, everyone that is able to do something, you need to be able to talk about the theory, the fundamentals, and be creative with those building blocks to create something new and unique, and then use these AI tools to help you create and execute on that vision that you have.
Yeah, yeah, yeah. I mean, and at some point it would be, well, where does the automation or the efficiency ends, right? Like, if you have a company, you say, well, I can automate the data entry. I can automate the creative, authoring, the copywriting, and so on and so forth. Eventually, you keep automating things. At the end of the day, that's just the owner of the business, right? Yeah. I think it was Sam Altman of OpenAI that was saying, maybe this decade we will see billion-dollar businesses that are literally just one person with AI agents, right? Just running things and selling enough. But the point that you make, I think is very, very interesting. I think it's going to be important over the next few years to start thinking about what a post scarcity economic system looks like. So if you get to a point where maybe only 10% of people work or can work, right? Because only 10% of the people have capabilities that are beyond the uh, the boundaries of what AI can do at the time, then what happens with everybody else? How does everybody else make a living or make money, right? Or afford other
Yeah.
things? I don't have the answers. Honestly, I don't think anybody has. Like, people have been talking about all sorts of different things, but we haven't figured that out yet.
Yeah. I think we're a long ways away from really understanding that. I think my theory would be I think everybody's going to become a farmer. Um,
Could be, yeah.
that's kind of the way it's going to go.
I think, we touched on a lot of stuff, so hopefully people found it interesting. We went through a lot of, as a history of AI and how it's useful, how it's different now, and I think it was very interesting to touch a little bit on, well, how is this going to impact people's, lives and jobs in the time soon. We didn't talk much about how does it affect drug discovery
Not yet.
today? But maybe we'll leave that for another episode. Um, but I think it was a very interesting chat. So thank you for joining me, and we'll continue this I guess on another occasion, and I hope people
Yeah.
found it interesting as well.
Yeah. I hope everyone enjoys kind of our conversation. I also really enjoy listening, more importantly, because there's a lot of stuff to talk about, and so it's really fun at the end of the day.
Awesome. Well, thank you so much, Dan.
Awesome.
It was a pleasure as always.
Pleasure is always mine as well. Thank you so much.